My next phylum, Platyhelminthes, also known commonly as flatworms. I can see why they're given that name, flatworms. Check out how flat their body plan is. These guys are the simplest animals with bilateral symmetry. They have a ribbon-like structure for that reason that it is so flat. Just checking that I'm recording. So I actually want to cover something that students get confused with. I've seen it previously. And so remember bilateral symmetry, I can cut it and get a mirror-like image, left and right, or mirror images of each other. They are the simplest animals with bilateral symmetry on the timeline. So I've already covered a phyla with bilateral symmetry, the mollusks, but just because I covered mollusks first doesn't necessarily mean that these guys are simpler. It depends what you're talking about here. I can actually see the different body plans. Here is a gastropod, a bivalve, and a cephalopod. Those body plans are quite complicated and more extended than these flat platyhelminthes. So just because I covered mollusks first doesn't mean that they're more simple. Platyhelminthes are the first animal I'm giving to you that have the simplest bilateral symmetry. Everything else will have more complicated bilateral symmetry. Okay, hopefully that makes sense. They have a highly branched gastrovascular cavity. It's seen here in this pink-like area on this image. So I can see all the branching occurring in that gastrovascular cavity. That's going to help increase surface area in order to digest their food. Digestion and excretion, both events are going to occur in this one opening that these flatworms have. They do not have a circulatory or respiratory system that's achieved through diffusion mechanisms throughout their body. Because their body plan is so flat, there's not a lot of room for empty space. They lack body cavities. These are acoelomates, recalling. They can be either parasitic or free-living. I'm showing you a free-living flatworm, commonly found in fresh water. They can also be parasitic. An example of a parasitic flatworm is a tapeworm. And tapeworms actually have, if I focus on the head of this tapeworm, I can actually have these hook-like structures. Check that out in this nasty little creature. And these suckers, that's going to help them attach to their host, where they can then acquire their nutrient needs by heterotrophic mechanisms. I knew somebody who had a tapeworm infection. Usually you're going to get this parasitic infection due to ingesting uncooked food. And so she ended up getting a tapeworm that ended up residing in her gut. And over time, she lost a lot of weight because that tapeworm was now sucking up those nutrients that her body would otherwise use. So lots of weight loss was shown in parasitism. Okay. Moving on, next phyla, Annelida. These are your segmented worms, more common name, segmented worms for the phylum Annelida. I can see how they got their segmented name with this body segmentation. Check it out. I can see the different segments, 1, 2, 3, 4, and so forth. It's quite obvious by the naked eye to see these body segmentation, these series of repeated parts. These guys have bilateral symmetry and a complete digestive tract. I can see the opening where food resources and other resources will enter this Annelida, and through a proper digestive tract will actually be excreted by another opening at the end, the anus. These guys have more space in their body plan compared to those flatworms. They have true body cavities. These are coelomates, recalling that body cavities are openings embedded in that middle tissue layer between the outer and the inner, and it's properly embedded in that middle mesoderm layer. These are coelomates. Next phylum, Nematoda, my favorite phylum out of the three for those worms. These guys are known to cause a different array of diseases in animals. So these are your roundworms, hookworms. If you've ever had a new puppy and been to the vet, you might recall an event where you're deworming the puppy, or you receive some sort of like yellow or white liquidy substance in order to give to the animal. Basically, you're trying to get rid of these guys. Your pet probably has these parasites, these worms that the vet saw at the clinic, or they're shedding the eggs of these nasty little parasites, and you're trying to deworm your animal. They're very, very common they have bilateral symmetry, a somewhat complicated body plan, tapered at both ends. What I mean by that is if you look at the middle image here, and here I can actually see kind of like a pinching effect going on at the very end. That's called tapering. That's going to occur on both ends of the nematode. They have modified body plans. They are pseudocoelomates, so they don't have a true body cavity. They have a false, a pseudo-false body cavity. It's false for the reason, do I have a picture? I do not. It's false for the reason that, remember, it's not embedded in that middle tissue layer. It's actually found between the middle, kind of that pinkish layer, and the inner layer. So it's a false body cavity, but it still exists nonetheless. These are important decomposers and parasites in plants and animals, as I suggested with a puppy example. We can also get these parasites as well.